Predictive maintenance is transforming the way industries manage machines. Let's understand building a practical predictive maintenance system using ESP32. In traditional industries, machines are maintained in two main ways: reactive maintenance and preventive maintenance. Reactive maintenance fixes equipment after it fails. Preventive maintenance services machines on a fixed schedule. The problem is that reactive maintenance causes downtime and losses. Preventive maintenance can be inefficient because parts are replaced even when they are still healthy. Predictive maintenance solves this by continuously monitoring machine health and predicting failures before they happen. Instead of guessing, we rely on real time data. Now, where does the ESP32 come in? The ESP32 is a powerful, low cost microcontroller with built in Wi Fi and Bluetooth. That makes it ideal for industrial IoT applications. With the right sensors, it can collect vibration, temperature, current, and sound data from machines like motors, pumps, compressors, and CNC equipment. Let's take a practical example: monitoring an industrial motor. The most common indicators of motor health are vibration, temperature, and current consumption. We can connect a vibration sensor, such as an MPU 6050 accelerometer, to measure abnormal oscillations. We can add a temperature sensor like DS-Ignite B20 to monitor overheating. And with a current sensor such as AC712, we can track power usage. The ESP32 continuously collects this data and processes it. At a basic level, we can set threshold values. For example, if vibration exceeds a certain RMS value or temperature goes beyond a safe limit, we trigger an alert. This is condition based monitoring. But we can go further. With the ESP32's processing capability, we can implement lightweight machine learning models. For example, we can extract features from vibration signals such as mean, standard deviation, peak amplitude, or frequency components using fast Fourier transform. These features can then be used to classify machine states like normal operation, misalignment, imbalance, or bearing fault. We can train a model offline using historical data and then deploy a compressed version of that model to the ESP32 using frameworks like TensorFlow Lite for microcontrollers. This enables edge intelligence, where the device makes decisions locally without sending raw data to the cloud. Since the ESP32 has built in Wi Fi, we can send summarized data to a cloud platform or IoT dashboard using MQTT or HTTP. This allows maintenance engineers to monitor multiple machines remotely. Alerts can be sent via email, SMS, or mobile notifications when anomalies are detected. From an architecture perspective, the system typically has three layers. First, the sensing layer, which includes vibration, temperature, and current sensors. Second, the edge layer, which is the ESP32 handling data acquisition, pre-processing, and possibly machine learning inference. Third, the cloud or dashboard layer, where long-term data storage, visualization, and deeper analytics happen. One major benefit of using ESP32 for predictive maintenance is cost effectiveness. Traditional industrial monitoring systems are expensive and often limited to large factories. With ESP32 based solutions, even small and medium enterprises can implement smart monitoring at a fraction of the cost. For engineering students, this is a powerful project opportunity. You learn embedded systems, sensor integration, signal processing, IoT communication, and machine learning all in one application. It bridges theory and industry ready skills. However, there are also challenges. Industrial environments are noisy, both electrically and mechanically. Sensor calibration is critical. Data quality determines prediction accuracy, and security must be considered when sending data over networks. In conclusion, predictive maintenance with ESP32 is not just a theoretical concept. It is a practical, scalable, and affordable solution for monitoring industrial machines. By combining sensors, edge computing, and IoT connectivity, we can reduce downtime, cut maintenance costs, and increase equipment lifespan. As engineering students, building such systems gives you hands on experience in one of the most in demand areas of modern industry: industrial IoT and smart manufacturing.